Alright, so welcome back everyone, and in this clip we'll talk about the fundamentals of collision layer. Well, collision layer is a very important attribute of the nucleus dynamics which decides the order of precedence and the priorities of nucleus objects. Every single nucleus object has its own collision layer, and nucleus objects with lower values of collision layer have got the abilities to dominate or push away the other nucleus objects having higher values of collision layer. Let's do one thing. Let's create a particle system and notice where exactly is this collision layer attribute. So for that, I need to create a particle grid. Let's go inside the nParticles menu and use the option nParticle tool. And with this, we can use the option create particle grid. All right. Let's close this and create the first click over here. And the second click can be anywhere in the grid, but make sure if you hit this in a diagonal way and press enter, you can get a very nice 2D grid of the particles with X and Z axis. Alright, so if you play the timeline, you can notice that these particles are actually falling under the gravity. Let's first of all change the render type of the particles and change them from point to the spares, and also enable the self collisions. Now we want the particles to stay upon the grid, so for that we can use the ground plane. Alright, so if I play the timeline, you can see there's a kind of a fickle in the first frame. If I get you back to the first frame and play the timeline, you can see the particles are actually changing their positions. Well, this can be solved very easily if we initialize the value of first frame with the current frame. So let's do one thing. Let's go inside the field solvers, and under the solver we have initial state. Let's initialize this thing and go with the set for the selected. So with this attribute, if you roll back the timeline, you can see all the particles are now stable and there is no more fickle. Alright, so now let's do one thing. Press Ctrl A and let us see where exactly is the collision layer. So the collision layer can be found inside the section collisions, and the second attribute is basically the collision layer. And right now you can see these white particles are having the collision layer value set to the 0. Alright, now let's do one thing. Let's create another particle emitter. Go inside the nParticles, use the option create emitter and reposition the emitter over here. Press Ctrl A and change the type from omni to the directional, and provide the directionality towards the X negative axis and add some more speed. Alright, we can also use some little bit spread, pretty fine, and get rid of with a higher value of the rate. So we'll use a value of 3. Okay, so right now let's do one thing. We'll also use the self collision of the particle 2, and let's play the timeline first of all. And here we go, we have the particle type with the render type set to the points. So change this to the spheres, and let's also change the color to take down some important changes and to differentiate between these two particles. So we have one set of particles with red color and another set of particles with white color. So at the moment both these particles are sharing the same values of collision layer. So it's quite expected that if this particle hit the white particles, this kind of displacement will take place, and the particles can now easily displace and offset the white particles, and this is something which is quite expected. Alright, now let's do one thing. Let's change the collision layer of the red particles from 0 to the 1. The moment you do this, you can now understand that the entire preference or precedence has now been shifted to these white particles. So if I play the timeline, you can notice that nothing is actually happening. Nothing is actually happening. However, these particles are colliding with the white ones, but still these red ones cannot just even able to move or displace or affect the white ones. Alright, so this is how the collision layer works. Let's do the reversal. Let's do one thing. Let's select the first particles, which is the white particle, and change the value of collision layer from 0 to the 1. And now we select the nParticle 2 and change the collision layer to the value 0. Alright, now the entire precedence or priority is on the red particles. If you play the timeline, you'll notice this is such a big and heavy change inside the overall motion of the particles. So now you can interpret and understand with this things that the importance of collision layer is really very important. So now you can interpret and understand that the values of collision layers, they do have a lot of big impact and they are extremely very important. All right, so I hope so this example is pretty much easier for everyone to follow and interpret the meaning of the collision layer. Let's take a pause, let's end this clip over here, and let's talk about the quick summary of our module. Alright, so let's take a quick look inside the summary of our module. So we begin with the basics of the nucleus dynamics, and we discuss about the various definitions of nucleus dynamics and the nParticles. We then create the simple forms of particle emitters like omnidirectional and volume-based emitters. Then we talk about the emission of particles from the polygon surface as well as from the textures. And finally, we have the emission from the curve, and then we talk about the n-particle collisions. Inside this, we talked about the n-particle attributes like self-collisions with respect to attributes like bounce, frictions, and stickiness. Then finally, we have the fundamentals of collision layer. All right. So with this, our module is now completed. Now let's talk about the next module, and let's begin with the process of creating Maya external forces and fields.